Welcome everybody. This is Mr. Ndabezita once again, and remember this time we will be looking at the exercises. So we have truly worked, and we are in exercise 1.2. We dealt with many of these in here. We looked at the domains and the ranges and everything that goes along with that. So in exercise 1.2, Thomas tells us to look at these algebraic combinations. In exercise 1 and 2, find the domain and range of f, g, f plus g, and f times g. So we are having them in here. These are the problems that we will be dealing with. You can see they are so many. So unfortunately we are not going to deal with everything in here, but we will try to do as many as we can in this tutorial. Right, the very first thing that we will do, it's problem 1. So we need to find the domain and range of f, and it is a straight line. We can just go into the function here, and I can just try to check. I can have a function which is defined by y. Remember, this is y is equals to x, and I can draw this from negative infinity to positive infinity. That is your choice, but I'm going to use minus 10 to 10, and this would show the beginning of the function and where the function ends. And I'm not going to give any description for that, and I'm just going to draw this with a black color. And when I press OK, let me just see what is happening here. Okay, let me just do this. Let me try to bring it a little bit higher. So this is what we have. It's a straight line. Remember, we have drawn from negative 10 to positive 10. So, but we know that the graph continues. We can just do this just to show that the function continues. So it keeps on going to negative infinity and positive infinity. So what would be the domain of this function? The domain would be the real number 16. X is an element of real numbers, or somebody can say from negative infinity to positive infinity. You will still be correct. So this was just a basic function that we have. We can go and look at the table of values, and this is what we have. When x is minus 10, y is minus 10 based on the function that we are having here, and these are the values. Never mind f prime and f second prime. So these are the table of values that we have. Okay, that is fine. So this is the domain. X is an element of real numbers, even y also. From negative infinity to positive infinity, y is an element of real numbers. So nothing is wrong with it. Let us go and look at g at x, the square root of x minus 1. So I am just going to come and edit this one. We are having the square root, so I am going to do the following. The square root of 1 minus x to the exponent of 0.5, which is the same as 1.5. So let me just check whether this is correct. Oh, sorry, it's x minus 1. So it is x minus 1. So x minus 1. And I can draw that function using the very same interval, but I know that it keeps on going to positive infinity. So the domain would be, please be very careful. Even if I want you to notice something, even when I have said it should start at minus 10 and end at positive 10, it cannot do that. Why? Because the square root of x minus 1 should be greater or equals to 0. Therefore, x should be greater or equals to 1. So it will start at x equals to 1. So the function is defined at x equals to 1 because the square root of 0 is 0. So when you come here, please check there will be no mistake. 1 minus 1 is 0. The square root of 0 is 0. So it will start at 1. The domain, when x is 1, y is 0. So this is inclusive, very much inclusive. So we have 1 inclusive is to positive infinity as the domain. And as you can see, the range is from 0. The function is defined at x is equals to 0. So we will have 0 is to 0 is to less than positive infinity. Let's try to investigate that. Okay, even if I can do that, everything will still be the same, but I want you to check something. No matter what value I can use here, I want you to notice just something. I want you to see what is happening to y. Okay, let me do this. I want you to see that even if I can increase these values the way in which I want, this function will never and ever go higher, as showing that it is heading towards positive infinity. I want you to see that. You see what is happening? So we are saying the range is 0 included is 2. It has to be less than infinity. It honestly has to be less than infinity. I think we dealt with this in the previous tutorials. So the range, it's from 0 inclusive is to less than infinity, positive infinity. This would be the range. You never and ever say that it is approaching infinity, as you can see. Let's try to do this just to demonstrate something to you. You see what is happening? Now let us use maybe 100. You see? And even if we can use 10,000, you see what is happening? So the range would be 0 inclusive is to, it has to be less than infinity. It has to be less than infinity. I think we will go back sometime just to verify that. Right, okay, that is fine. We have the domain and the range of the first one, and then they said we should find the domain here. Sorry, let me check something here. In exercise 1 and 2, find the domains and ranges of f. I've done that for f and g. And then I need to find f plus g and f times g for 1 and 2. So for 1, I have found the domain and range of f and the domain and the range of g. Now I want to find the domain and the range of f plus g. I'm combining two functions. And remember, there are some restrictions here. What I'm going to do here, I want you to be very careful. I'm going to draw the graph of this function, f at x equals x, so that we may see the demonstration more clearly. So what I'm going to do there, I'm going to insert a function, and I'm just going to say x, and I'm going to draw this from -4 is to 4. And I'm going to do the same for also this one. I'm going to draw this, I don't have to say negative there. I'm going to say 4. And let me just use a different color there. Let me just use red. So these are the two functions that I have. Right, separately, as you can see. And now I want f plus g. Right, f plus g. I want to find out the domain for this one. I know the domain here, x is an element of real numbers, and here the domain 1 inclusive is to less than 1 inclusive is to positive infinity for the domain, but for the range is 0 and less than infinity. Okay, that is fine. Now I want the 2 now. Now what I'm going to do, and then we will look at the algebraic way of looking at this so that we understand what is happening. So what I'm going to do there, I'm going to come in here, and remember I'm combining the two functions. So what I will do, I will have the function x plus the very second one, which is the square root of x minus 1. So I'm going to do this. What is that? It's x minus 1 to the exponent of 0.5. Now I want to see how that function would behave, and I'm not going to specify anything in here, and I'm going to draw using that, and then I'm just going to press OK, and I want to see what I can have in this one. So I have the first function x plus x minus 1 to the exponent of 0.5. Just to ensure that I'm correct, I'm going to draw this from, okay, let me just leave it like that, because even if I can say from -4 is to +4, let's just check what we will have. So this is the type of a function that I get, and I want to find the domain of this function. Right, what I'm going to do, I'm just simply going to use algebra, and I know that I have f at x. I know that I have f at x that is equals to x, and I have g at x that is equals to 1. Is it 1 plus x? It's x minus 1. So I have x minus 1 to the exponent of 0.5. I have these two functions. Now I know for the first one, the domain is from negative infinity is to positive infinity. And for the second one, I know that x minus 1 should be greater or equals to 0. Therefore, x should be greater or equals to 1. And now I need to find the intersection of the two. So I have 0. How am I going to demonstrate this? Okay, I have 0 and 1. Okay, I have 0. Sorry, I have x should be greater or equals to 1, and negative infinity is to positive infinity. But to accommodate that, I'll have to get rid of this for the domain. I will have to get rid of this, and by doing that, now the intersection of those two where they are both met. So this should be from 1, so the domain would be from 1 is to positive infinity, and infinity is not included. So this would be the domain, and this is what we expect from that. Can you see that domain? It's from 1 is to positive infinity, and it corresponds very much with this, because the function is defined at x is equals to 1. We can even just check that. When x is 1, let's check. When the value of x is 1, y is also 1. So this is exactly what we are saying there. So when x is 1, y is 1. So it is defined there. But remember, we are looking at the domain. So from 1 included is to positive infinity. And this is exactly what we have there. Okay, that is fine. I hope and believe that we have understood all this. I don't have the memorandums for this, but I'll try to download the solutions for this Thomas. But I believe and think that we are doing things fine. So that was f plus g, the domain. But they also said that we should find the range. Now let me show you something. Even if we can increase this to say maybe 100, we will have that. Now look what is happening here. Now things are a little bit different now, because remember the range of this function was in such a way that it was 0 included and less than infinity as the range. But now things are different. When I come here and I increase the range, let me do this and press OK. Nothing is changing. So this time look where the graph is heading. Now you see the graph, and I want you to notice something with the axis there. Right, so I want to keep on going. Now I want you to see what is happening here. You see? Now let me go down. Okay, let me just do this, because I want us to see what is happening there. Now if I compress the intervals, the x and y, like this, and look what I'm going to do now. I'm going to increase this to 10,000, and you see what is happening. Look, it is now heading towards infinity now. Do you see what is happening? It is now heading towards infinity. So we are therefore saying, let me just do this as many times as I can. You see, it just keeps on going upwards, because if I can increase this by another 0, I want you to be aware what is going to happen here. You see, so things are very much different here, very, very different. So the range would be, let me get back here just to say 10, and I try to do this, and I just simply try to do this. Let me just try to do this.
It was tough, like the charges said. Everything was fine the way I baked it. Everything. The only thing is,
let me just try to do this. Let me just try to do this. What am I doing? Jesus, my Father and my God. Why are the values like this? Okay, let me check the interval. Okay, let me just say 5. Looks like I have one, but we can see that it's from 1. The range is from 0 is to positive infinity. We can see that. Please, I don't want to be confused. We can see that, please. the range is from 0 is to positive infinity. Please, let's just leave it. I'm already tired. Right, and that was f plus g, the domain and its range. We have found that is fine. And then we go to number 2, and then we try to find the domain of that. Let me get rid of this. Let me just get rid of this. Let me just delete this. Let me also delete that. And let me also delete that. Right, and let me just say new. No. Very good. Here we are back to business. Now, what I'm going to do there is to find the domain of this function. Okay, that is fine. The square root of x plus 1. So I'm just going to come here and say x plus 1 0.5, and I have my function there. Very important. And how do I find that? X plus 1 should be greater or equals to 0. X should be greater or equals to minus 1. That's why it begins at minus 1, and the function is defined at x equals minus 1. So I can immediately see the domain here. It's minus 1 inclusive is to positive infinity. Remember that we are dealing with the domain. And the range, again, let me just try to show you something. We can specify the interval here to say from minus 3, I know it will never go there, is to 5, for example. So this is the start and this is the end, and I can draw that. But I want you to notice something in terms of the range. In terms of the range, let me increase this to 50, and I want us to notice what is happening here, whether the graph is heading upwards or not. You see? And let me now increase this to 500. I want you to look as to whether this is going up or not. You see? So the range is from 0 inclusive. Very important. The function is defined when x is minus 1, y is 0. 0 inclusive is to less than infinity. Less than infinity would be your range. All right, and then let's go and draw the second one, the square root of x minus 1. The square root of x minus 1. So we will look at the square root of x minus 1. And I'm going to use a black color. And I'm going to draw that from minus 4 is to positive 4. And there it is. So the domain would be, remember, 1 inclusive is to positive infinity. We dealt with that. And let's check now the range. And this is fascinating stuff. So let me increase this to 50. You see, it lies just below this function. No matter how far you can go, it will always and always be below, as you can see there. So okay, that is fine. Let us continue in this. Right, let me just put it here. Let me just do that. So even if I can come here and just increase this to 500, it will always be below. So the range would be 0 inclusive less than infinity. 0 inclusive and less than infinity, because this is positive. Okay, that is fine. Now let's find f. Oh, sorry. Okay, no, let's find f plus g, and then we will come back here and do f times g. I'm very sorry. So let's find f plus g now. So I'm going to take I'm going to do this. and I know that I have f. There it is. It's x plus 1. So what I'm going to do is to do this and say x plus 1 raised to the exponent of 0.5. Good. Plus, and I'm going to say x minus 1 raised to the exponent of 0.5 and close that. And then let's just try to see what we can have. So I'm going to use a red color, and I want this to start and end from -5 is to 5. And then let's see what we have. This is what we have. Let me just do this very quickly. Okay guys, I am back. We can continue. So let us see this. Let us see this, because we can see that the range of this function, very important that we notice that it's a point of intersection of the two graphs. So let me just come here. Let me just press here, and when I am there, let's try to find a table of values. Right, let's try to check what is happening here. I know the most important thing that I need to note there with these two functions is that x plus 1 should be greater or equals to 0, x should be greater than -1, and x should be greater or equals to 1 here. So I have -1 and 1. I have -1 and 1. All right, that is fine. So here we have a complex number, very complex there. And then let's continue in this. When x is 1, these are the values of y. So can you see that when x is 1, y is 1.4, and it is a value somewhere there, right? So remember, we are looking at the range here, and let me take you through. Let me just say close. Let me take you to a notepad, and I know for the first one, this one, x plus 1 should be greater or equals to 0. Therefore x should be greater or equals to -1 for the first one. All right, and for the second one, x minus 1 should be greater or equals to 0. Therefore x should be greater or equals to 1. And now I can see, in order to accommodate the two, I need to include both -1 and 1, and they are both inclusive. Now I need to check if this qualifies for both on the function here. Right, for minus, I cannot do that because of this function. The domain of this function is not the same as the domain of that function, and I need to accommodate this one. So what I should do there is to ensure that the domain of both, remember the domain of both should be 1 inclusive is to positive infinity. That would be the domain of both. Please be very careful here. This is not true. This is not true for the domain. Why? Because this function is not defined at x equals -1. So I need to check a place where they are both defined, and that's there. So the domain would be 1 inclusive is to positive infinity for the domain. And then for the range, we need to be very careful. Remember the value here, it's 1 point something. Don't save. We saw that when x is 1, y it's 1.4. Right. So for the range, I can try to increase this in any way that I want. I can even say 500. And I can even say maybe 5,000. Remember, I want you to check this. And from there, so the range would be 1.4 inclusive, 1.4 something. Let me just look at that. So I would say 1.4142, the range less than infinity. The range would be 1.4142 less than infinity. That would be the range of that function. Makes a lot of sense to me, but we will check when we go through the solutions of this problem. So that was 1 and 2. Now let me go back here and look at the multiplication of those two functions, what we can have. So by just using algebra, we can also find that. We can just come here, and when we are there, we can say, all right, x, and I am multiplying this function with that function, which is the square root, which is the square root. Now let me not use WordPad. Let me go and use another software. Let's use this one because it has the square roots and everything, so it's much more easier to work with that. So let us try to check what would happen there. Now when we are here, we have the first function, which is x, and we are multiplying that by the square root of x minus 1. So we are multiplying by the square root of x minus 1. Let me just check. Yes, x minus 1. And we want to draw that and find the domain and the range. So, sorry, back. Let me just go to the other side. Good. So what is going to happen there? What is it that is going to happen there? Now when I multiply the two, I want to get rid of that. So what I'm going to do is to say x multiplied by x minus 1 to the exponent of 1/2. There it is. Right, from there I want to multiply, and remember, when you multiply numbers of the same basis, you add the exponents. The bases are not the same, so I might just leave this the way in which it is, but I know how to draw a graph of this function. So I can come here, delete this one, delete that one, and edit this one. So what is it that I want to achieve here? I want to achieve x multiplied by x minus 1 to the exponent of 0.5. Let me check if this is correct. X minus 1. Yes. And to make things not complicated for me, no mistakes, I will do it in this way. And I'm going to draw this from, let me just say, from 5 minus 5 and 5, and I'm going to use this, and let me draw that. This is the function that I get. Now I want to find the domain and the range of this. Now, will it be possible if I look at these two functions that are multiplying one another and do the following? Oh Jesus, Okay, I have f at x is equals to x, and I have g at x, and that is equals to the square root of x minus 1. Now suppose I have them like this, and you are in the exam and you don't have a graphing software in order to work out the domain then. So what would you do then? First thing, you know that the domain of the first one, it's x is an element of real numbers, and the second one, you know that x should be greater or equals to, sorry, this is not 16, this is 1. X should be greater or equals to 1. So you want to know the domain. You know you cannot accept negative numbers, so you will have to say from 1 to infinity as your domain. Let's check if that is true. 1 is to infinity as your domain. Now, to check if this is true, let's try to increase our interval to 10. Remember, we are looking at the domain here, and I want you to notice something. At x is equals to 10, let's check the y values. At x is equals to 10, the value of y is 30. Is it true? Yes. Now, what I'm going to do, I'm going to increase the interval. We want to check whether it is heading towards positive infinity or not. And I'm going to use 100 here. And I'm no longer going to try and pull this just as I have done. I'm just going to come here and just say, to 100. And I'm just going to say calculate. And I'm going to go to the end of this. When x is 100, look at the value of y. It keeps on increasing. When the value of x is 94, look at y. So if I keep on increasing this, look what is happening. Calculate. Look. When x is 1000, you see the values of y. The values of y. So in other words, the domain here, when x keeps on increasing, y also increases. Remember, we are looking for the domain here. So we can see that when you increase the values of x, so will be the values of y. And I can increase this again. I can say calculate, and I can have that. So where is it heading? Positive infinity. The domain would be 1 inclusive is to positive infinity. That would be the domain. And now let's check the range. We can clearly see that it is defined at x equals to 0, y is 0. So that would be 0 inclusive is to positive infinity, because I can see that the values of y increases as the values of x increases. So that solves the first multiplication here. Let's come to these ones. I know how to multiply here. I know how to multiply them. So when you have the square root of x plus 1, which has to be multiplied by the square root of x minus 1. Let's just check very quickly. Yes. So when I multiply the 2, I know that I just have to have one square root and I multiply those two. So I just say x plus 1 into x minus 1. This is exactly what I have. And I think I can draw a function of this nature. Right, let me try to do that. So what I'm going to do is just to say x plus 1 into x minus 1, and all this is raised to 0.5, and I'm going to draw that like this, and this is what I get. This is the function that I get. And note that you are having two pieces here and you want to state the domain. So what I can do, I can increase this. I can increase this from maybe minus 10. And you see it goes that side. So the domain would be negative infinity is 2 minus 1 inclusive. The union of 1 is to positive infinity. That would be your domain. And your range, I can see that the function is defined at x equals to 0, y is 0. When x is 1, y is 0. So the range would be 0 inclusive is to positive infinity. And we can investigate that. I can say, okay, minus 100. I want you to notice this. And I also want you to notice that. You see? And we can just demonstrate that by using a table of values there. And I can have them like this. The function is defined on both negative and positive x values. So there it is. You can see that when x is 10, the value of y is that, and as x increases, y is increasing. So that would be the domain and the range of that function. And just check how much of time we have spent in here, just looking at two things, because I'm trying to explain thoroughly that we both understand, and whenever there are mistakes, we are more than welcome to talk about that. So I'm going to pause the video here and I will see you after some time. Alright, let us continue, guys. I think it is very important that we try very much to understand how things should be. So we have dealt with number 1 and number 2. That is fine. We now have to go to number 3 and number 4. In exercise 3 and 4, find the domain and the range of those functions. Okay, that is fine. F at x is equals to 2. And the best way to do these things is just to use a table of values. That's why I most of the time refer to this table, so that you can see what is happening here. Y is equals to 2. And I'm going to draw this from minus 5 to positive 5. This is my argument range. And this is the function that I have. And I can just go and check the table of values from minus 5 to 5. Okay, right, and then we calculate that. So this is the table of values. For x is minus 5, y, you keep on getting the same value of y. And does it correspond with what we are seeing here? This is true. For every different value of x, you will have the same value of y, which is 2. So it's very important that we note these things. So we want to find the domain of this and the range. So by just merely looking at that, the domain would be from negative infinity is to positive infinity. And why are we saying that? We can come here and increase to minus 10 and 10, And I want you to notice what is going to happen here. You see what is happening. So the function moves from negative infinity is to positive infinity. That would be the domain, the values of x. And as to the range, you can see that the range of the function was already provided that y is equals to 2. That would be the range. Now you ask me, remember we are speaking about the range, y is equals to 2. And this 2 is inclusive because the graph is defined at this. So the gradient is 0 and the value of y, the y-intercept is 2. So that would be the range of the function, y is equals to 2. Okay, that is fine. Let's go to x squared plus 1. Let me just do this and just try to find x squared plus 1. And I'm going to start this from minus 5 to positive 5. And let me just use a different color. And I want to have the starting and the end. And I can draw that graph. And you can see that the graph has been shifted 1 unit upwards. So this is the parabola. And I want to find the domain of this function and the range. So I can see that the domain, let's check here. For the value when x is minus 5, the value of y is 26. So let us try to increase the values of x and see what will really happen here. Minus 10 and 10. And let's try to calculate. Now look what is happening. As the values of x increases on negative side for x is less than 0, let's check the values of y. As x decreases, so are the values of y, and as x increases, so are the values of y. So we can even come here and use 100 and we can calculate this, and this is what we have. So the domain would be from negative infinity is to positive infinity. And let me just try to demonstrate this. And I want you to check what is going to happen here. So let me increase this to 100. And I want you to check what is going to happen here. It has to go to that side. From minus 100 to 100. Okay, that's fine. We press OK. Now I want you to check what is happening. I want you to check something here, the values there. So I'm trying to go, okay, let me do this. You see the graph keeps on widening. You see, check what is happening. You see, keeps on going to infinity. There it goes to infinity now. So we are therefore saying the domain of the function is from negative infinity is to positive infinity. That would be the domain of the function. Right, I hope you saw that. And then as for the range, we can see that the graph is defined at y is equals to 1 and it's inclusive. So 1 is to positive infinity would be the range. So nothing new about that. Now from there I have found the domain of f and g. Now I want f divided by g. F divided by g. So I'm just dividing the two. So I can do that. Let's just see what type of a function we will have when we take f, which is 2, and we divide this with x squared plus 1. Let's just try to check what we would have, and I'm going to draw this from minus 5 is to 5, and I want this to be the beginning and this one to be the end. So let's have that function. Here is the function. When we take the first one, f, which is 2, and we divide it by x squared plus 1, and we get this function. Let me just use a different color there, and I'm going to use this color. You see, oh, it's not so clear. Let me try to use this color. There it is. So this is the function. Now I want to find the domain and the range of that function. Now, how do I find the domain and the range? Now, the first thing that I will do, I will check here. Please note that the function is defined at x equals to 0, and I can increase this interval. I can increase this interval to say, for example, minus 100 is to 100. And you can see now what is happening. Let me show you. Remember when it was minus 5, we could see the end and the beginning. Let me show you. You see? Now let me increase the interval. Let me just make it minus 10 so that you can see what is happening. And 10. And this is what we get. You see the graph keeps on going from negative infinity is to positive infinity, and is defined on the entire real number line. Very important to note that. So the domain would be negative infinity is to positive infinity, and then from there that would be the domain. And the range, notice as we increase from left to the right, this value stays there. So the range would be 0. Let me show you something. 0 is to 2, and they are both inclusive. 0 is to 2. That would be the range of the function. Now that we are done with those ones, now let me go to G. Now dividing f, x squared plus 1. So I'm going to get rid of this one, delete. Okay, let me just edit. So this time I'm going to do this. Now G divides f, and let's check what we can get. You see now what is happening. This is the function, and let me just try to use maybe minus 3 to positive 3, and look what we have. So this would be the function that we have if G divides f. We have this function. So remember, we are having the graph of this function divided by 2. So the graph is shifted by a unit of 1/2 upwards. The graph is shifted 1.5 units up. So what will be the domain here? We know that it will be negative infinities to positive infinity, or x is an element of real numbers. And then let's look at the range. The range would be irrespective of us increasing the interval here. We can say minus 10 and 10 here. And I want you to notice what is going to happen here. Nothing is happening. So the range would be 1/2 inclusive. Let me just be sure of this. Let me use minus 3 is to positive 3, and let's just calculate. So check. When x is 0, you see 0.5 will be the value of y. So the range would be 1.5 inclusive is to positive infinity. And then I'm done for this. Now I go here, and I can try to have these functions. y is equals to 1, and I can draw this function. There it is. And then secondly, I can have 1 plus the square root of x. So I can come here and have 1 plus the square root of x. 1 plus the square root of x, and I can draw this from minus 5 to positive 5, and when I press OK, this is the function that I have. Right, now what is the domain of this function? What would be the domain of this function? Now the domain would be negative infinities to positive infinity, no doubt. That would be the domain. It is defined on the entire real number line, and the range would be 0 is to 1. 0 is to 1. Very inclusive, and 1 is included because the function is defined at y is equals to 1. That would be the domain and the range. And then for this one, let me just get rid of this one. So for this one, what would be the domain? The domain would be from 0 is to positive infinity. That would be the domain. But what would be the range? Let us check what the range would be. Suppose I increase this. I don't even have to go to negative because it is not defined on that side. So I can just leave this, and I can increase this to maybe 100. And I want you to notice what is going to happen here. Right, let's go to a table of values. So let me just say 100. And I want us to check whether this is heading towards positive infinity. Look what is happening. It will never and ever approach infinity. Never. Look, you see. So the range would be from the function. The range would be from 1 inclusive less than infinity. 1 is to less than infinity. It can never and ever go to infinity. You can see even from here. You can see from here. You see what is happening. These values would never and ever. You can have another 0 here, and it will try to calculate. Oh Jesus, it's processing things, but it really doesn't matter. But we can see that. You see the values there. So we are therefore saying the range of this function is 1 inclusive less than infinity. That would be the range. Okay, that's fine. And that was the domain. The domain and the range. The domain and the range, that's fine. And now f divided by g, 1 divided by that. So let's see such a type of a graph. So 1 divided by g. So I'm just going to copy this and paste it there. Divided by g, and what I'm going to do here is just to have this so that I don't run into mistakes. Right, so this is the function that I will have, and then I will press OK. Let me just get rid of this. so that we see clearly what we have. So we have we have f divided by g, which is 1 divided by that. Sorry, 1 divided by that, and this is what we have. So we want to find the domain there. The domain would be from 0, and this 0 is defined, it is inclusive. The function is defined as at x equals to 0, so 0 is to positive infinity, because we can try to increase these values as we wish. Let me just do this, and we can calculate that, and we can see that when x is 100, the value of y is approaching a value that is very, very less. Let me just calculate once again and check what is happening. You see what is happening here. The value now becomes constant. Let me add the last 0 to calculate, and look what we have. You see, so the function is heading towards 0. So the domain of the function, as you keep on increasing values of x, so the domain would be 0 is to infinity, because we can see that we can increase the values of x as we wish. You see, so the function, let's see, when x is 0, y is 1, and we can see that. So from 0 is to positive infinity, that would be our domain. And then our range, what would be the y values? Let us check just here. Right, I know that it is not defined when x is negative. We are having a complex number there. It begins to be defined when x is 0, y is 1, and when x is 1, the values of y keeps on decreasing. So we can say 0, the range would be 0 is to 1, and 1 is inclusive. That would be the range of this function. 0 not included, open bracket, 0 is to 1 inclusive. That would be the range of our function. Very, very important, because we are stating the range from a smaller value to a bigger value. All right, that is fine. We are done with f divided by g. Let's go to g divided by f. So let me just come here. So we are just going to do this, and let me just draw the graph. There it is. The domain 0 is to positive infinity, very important, and the range would be, let me try to increase the values there. Let's check. When x is 100, the value of y is 11. You see what is happening, and I can increase this to 1000, and I can calculate, and I will just find 32 point this. So the range would be 1 inclusive less than infinity. That would be the range. Alright, that is fine. We have dealt with all this. Now we go to number 5. Composites of functions. If f at x equals x plus 5 and g at x equals x squared minus 3, find the following: f at g at 0. Now I'm going to approach this in 2 ways. Now the first way, I'm going to use a notepad. Don't save, and let's go here. And what I'm going to do in here is the following. I know that I'm defining the graph of G inside the graph of F. So I'm going to write f at x, which is equals to x plus 5. This is what I have. And then from here, I'm going to define the graph of G. Right. And then where I see x, I'll be writing x squared minus 3. So f at x squared minus 3 is equal x squared minus 3 plus 5. And then let me simplify that, and that would be equals, let me just do this just to speed up things, and this is equals to x squared plus 2. Right, this is what I have. This is f at g at x. Now let me go and now substitute 0 where I see x now. So f at 0 is equals to 0, that is squared, plus 2. And what would be the answer for that? What is 0 squared? It's 0, and 0 plus 2, the answer is 2. So f at g at 0 is 2. Now that would be the first way of looking at this. Let's see if we find g at 0 and then define it inside of f, whether it will give the same thing. So I have g at x, that is equals to x squared plus 3. Okay, sorry, minus 3. Then from here I want to find g at 0. G at 0 will be equals, where I see x I put 0, so that would be 0, that is squared minus 3. And what answer will that be? 0 squared is 0 minus 3, so I have this minus 3. So g at 0 is minus 3. Okay, that's fine. Now let me go and write f, which is equals to x plus 5. Are we fine? So what I'm going to do, where I see x, I'm going to write minus 3. So this is just to say f at minus 3, and that would be equals to minus 3 plus 5, and that would be equals to 2. Exactly the same thing that we found in there. So the choice is truly yours, how you want to do these things, but I see this one as the most simplest way of looking into that. So we are fine with this. Let's go to that one. We are now defining f inside of g. So you will have your g at x. There it is. Let me just copy this and paste, and you will have your f at x. Let me take that and paste. Right, and then from here we are defining the graph of f inside the graph of g. G at f at x. This is what we are trying to do. Now let's just do everything all at once. Let's do everything all at once. So f at 0, I know this will be 5, and then I'm going to substitute 5 in g. So what I'm going to do is just to say 5 squared minus 3. So what is 5 squared? It's 25 minus 3, and the answer would be 22. So that would be the answer for that. So first of all, I find f at 0, which is 0 plus 5, that is 5, and then I'm going to substitute 5 inside of g. That would be 5 squared, which is 25 minus 3, it's 22, and then you are done. You are done. Alright, so I'm not going to solve everything, guys. Please, you will do these ones. So let me just continue with something else. And I'm also not going to solve this. You will deal with that. I'm going straight to exercise 7 and 10. Write a formula for fog. So we have FOGOH. We have 3 functions this time. Did Thomas show us how to do this? No, he did not. So how do we do this? Okay, that is fine. The first thing that we are going to do, we know what this means. We are defining the graph of H inside of the graph of G inside of the graph of F. This is exactly what we are doing there. Okay, that's fine. We can try very much to do that. So what I'm simply meaning is the following. So this simply means you have f at x and you have g at x and you have h at x. So you are defining the graph of h at x inside the graph of g at x, and together of them are defined inside of f at x. So this is f at g at h at x. So this is exactly what we are doing there. This is exactly what we are doing there. So let's see whether we will succeed in this. So I am provided with 3 functions. The first one is f at x. Okay, let me do this. F at x, which is equals to x plus 1, and I have g at x, which is 3x, and I have h at x, which is 4 minus x. So this is exactly what I have. And then from there, I want to define the graph of h inside the graph of g, and together inside the graph of f. So I'm going to try to do these 2 ones first. I'm going to define h inside of g. So in here where I see x, I'll be writing 4 minus x. So g at h at x. So this would be equals to 3, where I see x, I'll be writing 4 minus x. There it is. This is g at h at x. So I can try to simplify that, and I will find 12 by distribution minus 3x. That would be the final answer. 12 minus 3x, and then I'm going to define this inside of f. So I'm going to say f at g at h at x is equals to 12 minus 3, and then where I see x, I'll be writing x plus 1. So I have this, and I'm defining this inside of that. What have I done here? No, I am defining this inside of that. So where I see x, I write 12x minus 3x. 12 minus 3x and then I have a plus 1. So I have the like terms there. 12 plus 1, it's 13 minus 3x. So that would be the final answer of f at g at h at x. So this is what we have. I hope this is correct, but I think it is. And then we did this one. I'm going to leave this one and that one for you. I'm going to solve that one. So we have f at x equals that, and g at x equals that, and h at x. So I'm going to define this inside of that. So I'm going to say g at h at x, it's equal. So I'm defining this inside of that. Where I see x, I write that. So it will require me to go to that other app that we have, because it has some square roots that we can introduce. So let's work with this one. Okay, I think it will load up in just a few minutes. Let me just check something and I will be back. Right, let us continue in this. So what I'm going to do, remember I am solving this one. So I'm defining the graph of h at x inside the graph of g at x, or inside of that function. So what I have in here, I just have, let me do this. I have x squared, so let me just do this. Sorry, let me do this. So what I have is x squared divided by x squared plus 1. This is what I have. And in this function, where I see x, I'm going to write the square root of 2 minus x. So I see x and I'm writing the square root of 2 minus x. And all this is squared. Very important that you see that. Very, very important. And I'm going to do the same thing. I'm going to copy this and I'm going to paste it there. Right, here I am. Now I want to simplify this. Let me just have an enter. Let me just have an arrow that points to this side. Very good. So I know this and this goes once into each other. You will be left with 2 minus x, and on the denominator you will have 2 minus x plus 1, because this into this also goes once. Right, and I can simplify that further, and I can just introduce this. So there's nothing I can do on the numerator. I will just leave it as it is. I will have my 2 minus x, and on the denominator I have some like terms. 2 plus 1 is 3 minus x. So this is what I have here. What is this now? This is defining the function g at h at x. Now I'm going to use this and I'm going to define it inside of f. So allow me to do this. Format text. Right, so when I'm here, I have this. I have this x plus 2, 3 minus x. 3 minus x. In this function, let me just have an enter back. Let me just say text, enter. Right, and then from there, let me just have an arrow. Very good. Let me take it backwards. There we go. Now in here where I see x, I'm going to write 2 minus x all over 3 minus x. Where? In here. So I see x there, and I'm going to write 2 minus x. So here I am, and I am going to write this. So let me just copy this, and let me just paste that, and then I should have a plus 2 there. Delete. Let me have plus 2 there. Very important, because I have this plus 2. Right, divide, and then on the denominator I have my 3 minus, and then where I see x, I'm going to put that. So it would be best if I do this, and what I'm going to do is to copy this and paste it in here. And let me just backspace. Let me just close that. So this is what I have. So you can simplify here by taking out the lowest common denominator and doing a lot of things, and then you will end up with whatever that you should end up with. Unfortunately, I'm not going to complete this because of time. Right, and then from there we saw that we dealt with this. So guys, let me just see what other problems there are. Combining functions, shifting and scaling. It's very important, this one. So let's come here. Let f at x be equals to that, and h at x express each function as a composite involving one or more. So we need to express this as a composite function with one or more, f, g, h and j. So as you can see that from number 11 we have a, b, c, d, e until f. So we need to express each of the functions in exercise 11 and 12 as a composite involving one or more, f, g, h and j. So we can try to play around with that, but let's continue with this in the next tutorial. This is where we will start at. Let's just continue with that in the next tutorial.